Welcome back, everybody. In this lecture, we're going to be discussing object-oriented programming. Object-oriented programming, or OOP, allows programmers to create their own objects that have methods and attributes, and it's a really great way, once you begin scaling your code, to organize your code. So recall that after we defined things such as a string, list, dictionary, or other built-in Python objects, we were able to call methods off of them with the .method name syntax, such as when we were able to call the append method off of a list object, or the index method off of a tuple. These methods act as functions that use information about the object, as well as the object itself, to return results, or edit or change the current object somehow, such as when you called .sort on a list, it went ahead and edited the current list. For example, this includes appending to a list or counting the occurrences of an element in a tuple. So those methods use information about the object and then either return a result or they edit and change the current object in some manner. OOP, or Object-Oriented Programming, allows users to create their own objects with their own methods and own attributes. And the general format is often confusing when first encountered, particularly because of the use of a self keyword. And its usefulness may not be completely clear at first for beginners. But in general, object-oriented programming allows us to create code that is repeatable and organized, and at a certain scale, you're going to need to understand how to work with object-oriented programming in order to make sure your programs themselves are flexible. And when you're working with outside libraries, you'll see how they make use of object-oriented programming in a lot of their code. So for much larger scripts of Python code, functions by themselves really aren't going to be enough for organization and repeatability. Commonly repeated tasks and objects can be defined with OOP to create code that is more usable, especially across an organization. So let's check out the syntax of object-oriented programming, and don't worry about completely understanding everything we show you right now. We're going to take it step by step in a Jupyter Notebook through a series of lectures. But for right now, I just want to give you a brief overview of some special syntax calls that we haven't really seen before. The first one being the class keyword. So the basic way that you define an object is using the class keyword. And that's why sometimes objects are also called classes in Python. Sometimes people like to interchange those two terms. But basically we have the class keyword and then we have the name of the class. And notice here that the name of the class now is following what's called camel casing, where every individual word has that first letter capitalized, which is why we were telling you before to have variable names and function names in lowercase, because classes, those are the reserved uppercase words and uppercase naming schemes. So we have class, and then we define the name of the class. The next thing we notice here is this thing that looks a lot like a function, but it's actually called a method when it's inside of an object or inside of a class call. And here we have def, just like we would with a function, and we have this special method called init method, and it's underscore underscore init, and this allows you to create an instance of the actual object. You'll notice here we have then a self keyword as well as some parameters to be passed. So param1 and param2 are going to be parameters that Python expects you to pass when you actually create an instance of this object. And then what it does is when you pass in a parameter, for instance parameter2, you go ahead and assign it to an attribute of the function. That way Python knows that when you're referring to self.param2, you're referring to the attribute param2 that's connected to this actual instance of the class instead of a global variable called param2. And we'll explain this in a lot more detail because this is a step that is really confusing at first. But again, all we're doing here is we're going to pass in a parameter and then connect that parameter with the use of that self.argument or self.parameter to link it to the actual object itself. After that, then we can have various other method calls. And these look a lot like functions. We say def, the name of whatever you want your method to be, and then you pass in that self keyword again to let Python know that this isn't just some function, it's a method that's connected to this class. And that's why we use the self word, to connect these methods to the class so that when you call something like self.param1, it knows that you're referring to the attribute param1 that's connected to the class itself. Okay, so we're going to explore object-oriented programming in a lot more detail, take it really slowly step by step in the next series of lectures. So if that was all kind of a real quick blur for you, don't worry, we're going to go step by step coming up next. We'll see you there. Welcome back, everyone. It's time to actually dive in with Python and use object-oriented programming to create our own objects. In part 1 of this series of lectures, we're going to focus on the class keyword as well as creating attributes for our objects. Let's jump to a Jupyter Notebook and get started. Alright, so let's start off by actually realizing what an object already looks like in Python. If I were to create my list, 1, 2, 3, I would be able to then call the variable my list, say dot, hit tab, and see a bunch of attributes and methods off of this object. And the same thing goes for a set. And we've seen how to create a set using my set equal to, and then we have this set keyword. And then if I take a look at my set, I can do dot tab and see a bunch of attributes and methods. What we're going to do is see if we can create our own user-defined objects. And everything in Python is an object. So I could say, what is the type of my set? And it will report back that it's a set. And I can do the same thing for that list I just created. It reports back that it's a list. So let's explore how we can use the class keyword to create a user-defined object. So these are built-in objects. Let's use class. That's C-L-A-S-S. That's our keyword here for a user-defined object. The class is basically a blueprint that defines the nature of a future object. And from classes, we can then construct an instance of the object. And an instance is a specific object created from a particular class. So we're going to now create the simplest class possible. So I'm going to say sample. Notice how my class name is capitalized. So by convention, for classes, we follow camel casing, which is to say that every word here starts with a capital letter, unlike snake casing for variable names and function names where we had underscores. So by convention, we use capitalized names for classes. So we have class sample word, and I'm just going to say sample here, open close parentheses, colon, and then we'll say pass. So recall that the pass keyword basically just says don't do anything, and it's a placeholder there. If we didn't have it, we would get some sort of syntax error in the file. So instead we have pass, and that's it. We've just created our first class. And all it's doing is just saying, hey, you create a sample class, and that's it. There's nothing else there. So let's create an instance of the sample class. We'll say my sample is equal to, and then we call sample, open close parentheses. We don't pass anything into it yet. Shift enter to run that. And if I check the type of my sample, you should see something that lets you know that it's a sample type. All right. So what we've done so far is we used the keyword class, created our own sample class. It doesn't really do anything. Then we created an instance of that class by saying the variable name is equal to an instance of sample. And then we can check my sample, and it says it's main.sample. Later on in the future lecture, we're going to discuss what this underscore underscore main underscore underscore keyword actually means. Basically, it's just letting you know that this particular instance of sample is connected to your main script here. All right, so that's the simplest class possible. It's not very useful though, because it doesn't have any attributes. So let's now see how we can create attributes. So inside of class here, I'm going to write 2 lines of code. I'm going to say def, just like we would for a function, except when it's inside of a class, we refer to this as a method. And this is a special method called the init method, which is going to be called upon whenever you actually create an instance of the class. And we always start off with the self keyword, which basically connects this method to the instance of the class, and it allows us to refer to itself. And then we pass in any attributes that we want the user to define. So for example, instead of calling our class sample, I'm going to say that it's a dog class. So dogs have attributes to them, and an attribute is a characteristic of an object. Later on, we'll discuss methods, which is an operation we can perform with the object, but for right now, we're focusing on attributes. So we may be thinking, well, what kind of attributes or characteristics do dogs have? Well, they have a breed. So something we may want to pass is the breed of the dog. And remember, when we had my set and my list, I could do dot tab and then see a bunch of options. Some of these are methods, some of these are attributes. What we're going to do now is try to create an attribute here so that when I create an instance of the dog class, I can hit dot and then see that breed pop up. So let me delete these lines because we won't need them anymore since the sample class won't be used. And then we will say self dot breed is equal to breed. And these 2 lines can be really confusing at first, since this is the first time we see the self keyword and we see the sort of like strange assignment. but I want to run this first and then break down what's happening in these two lines of code. So let's run this, and notice my indentation there. Everything's indented a little bit. And let's create a variable. I will say my dog is equal to an instance of the dog class. Now, if I don't pass anything, I will actually get an error. So you'll notice that we actually get an error when we run this with no positional arguments because we are expecting the breed parameter. So what this Python is trying to say to us is, hey, when you create a dog, it's expecting you to pass in a parameter for breed. So let's do that. We're going to say breed of the dog is a lab. And now when we run this, we don't get an error, and I can check the type of this my dog variable, and it says, hey, you now have an instance of the dog class. And if I say my dog dot and then hit tab, I should be able to autocomplete breed. Now the reason breed autocompletes is because right now it's the only attribute. Later on when we add in more attributes, we'll see a drop-down list. But if I run this, it reports back, hey, this instance of the dog class called my dog, its breed is lab. So let's scroll back up here and break down what's going on. Init can basically be thought of as the constructor for a class, and it's going to be called automatically when you create an instance of the class. This self keyword, it represents the instance of the object itself, and actually most object-oriented languages pass this as a hidden parameter to the methods defined on an object. But Python, it doesn't do this. You have to declare it explicitly. And by convention, we use the word self here. Technically, you could write in any variable name you wanted, but you should definitely stick with self. That way other programmers, when they look at your code, it makes sense to them. Now, I want to focus on breed because I found it confusing when I was just beginning that you see breed here 3 times. You see breed, self.breed is equal to breed. And I want to show you something that's not going to be correct convention-wise, but will hopefully help you understand how breed is being worked into this entire object. So what happens is when you create an instance of the dog class, Python is going to call this init method, and it's going to use self in order to represent the instance of the object itself, and then it's going to expect you to pass in this argument, breed. And I'm going to call this my breed. And what happens is when you say my breed here, I can set my breed here, and then you assign the attribute equal to whatever this parameter was. By convention, these 3 have the same name, but I want to show you how changing the name will hopefully make this clear to you what the actual connection is when you pass in the parameter. So I'm going to rerun this. And if I take a look at dog and then do shift tab, and you can also call help on dog, you'll notice that it's expecting my breed to be passed in. So what happens is you pass in this variable for my breed, and then the next step is you take whatever variable was provided for my breed and then set it equal to the attribute .breed or self.breed because this represents the instance of the object itself. So all we're doing when it comes to attributes, which again are characteristics of the object, later on we'll learn about methods, is we take in the argument. In this case, it's my breed, and we assign it using self.attribute name. So that's just the convention of what you're actually typing, self. And then you choose the attribute name. In this case, I'm calling it .breed. So let's run this again. Make sure you rerun this cell so we have my breed there. And then I can say my breed is equal to, let's say Sam's a husky now. I run this again. I still have a dog class, and if I take a look at my dog, if I hit tab, I only have breed. I don't have my breed available because my breed was just a parameter name we chose for the argument. So we said, oh, pass in the my breed argument, and I'm going to assign it to self.breed here. And I want to make this even more clear by saying breed is now my attribute. If I run this again, what happens is I pass in again my breed is husky, the type again stays dog, but if I say my dog tab, it's now my attribute, and it happens to be husky. So all we're doing here is you pass in the parameter or argument, and then it gets assigned to the attribute that you can later call on your object. However, by convention, you're just going to use the same parameter name for all three of these, which is why you end up seeing something like self.breed is equal to breed, and you pass in breed. This is confusing at first for beginners because they see breed in here 3 times, but you can tell that once you're familiar with object-oriented programming, it's just cleaner to have all 3 of these be the same term. That way you know what's being passed in and where it's being assigned. There's no real reason that they should all have those separate names. So right now, our dog only has a breed, but let's go ahead and give it more attributes. So what else could a dog have? Well, a dog could have a name. And maybe we can say, does the dog have spots or not? So we have a breed, name, and spots. So here we just say, create some more attributes. Self.name of the dog is equal to whatever name you pass in, and self.spots is equal to whatever you pass in for spots. And notice here, what I'm doing is I'm kind of expecting certain data types to be passed in. I expect breed to be a string, I expect name to be a string, and spots, the way I'm thinking about it, is actually going to be a Boolean. So let me have a comment here. I expect a Boolean, true or false, does the dog have spots or not? So hopefully you get the idea here that not every attribute you pass in is going to be a string, but it can be an integer, a floating point, it can be a list, it can be a lot of stuff. So I rerun this, and now let's take a look at what we need to define our dog. We need the breed of the dog, the name of the dog, and true or false, does it have spots? So we'll have the breed of the dog be a lab. We'll have the name of the dog be Sammy. And we'll have spots be false. Sammy doesn't have spots. So I run this, I run that again, I still have that dog class. But now when I say my dog and I hit tab, I see the options. I can see breed, name, and spots. So I can call these, check what the breed of that instance of the dog class is. I can check what the name of the dog is, and I can check, hey, does the dog have spots? And it'll tell me false, it doesn't have spots. One of the issues with Python being so flexible is that later on, when you're a programmer and expecting other people to use your classes, you're going to need to add in some documentation to let them know, hey, I'm expecting strings for breed, strings for name, and spots should be a Boolean. Because right now, I could say something like no spots, and Python's not going to complain here because I didn't do any sort of type check to make sure spots was a Boolean. So if I were to run this all again, there wouldn't be any error. Just when you say .spots, it would print out that string spots. Okay, so those are the very basics of attributes. We'll discuss better ways to have type control to make sure things like spots are Booleans later on in the course. But right now, what I really want to focus on is the basic idea that you use the class keyword, then with capitalized names, you define the name of your class, and the very first method in your class is going to be a special method called the init method. And this init method acts as a constructor, and we have this self keyword, which is a reference to the instance of the class. So that instance of the class is then going to have these dot attributes that you pass in based off what parameters you define up here. And by convention, the parameter name, the attribute name are the same, which means you will see it 3 times. Once when you pass it in, and then once here for the attribute, and once for the actual assignment call. Okay. Those are the very basics of creating attributes. In the next lecture, we're going to discuss class object attributes, and then we'll move on to talking about methods. We'll see you there. Welcome back, everyone. In this lecture, we're going to be discussing object-oriented programming again, and particularly, we'll talk about class object attributes. And these are attributes that are going to be the same for any instance of the class, and then we'll move on to discussing methods, which are basically actions that you perform with the object you created. Let's jump back to the Jupyter Notebook where we left off last time. Okay, so here we can see our dog class that we created last time, and we also saw how the user could define various attributes. They could define the breed of the dog, such as Lab or Husky or Golden Retriever. They could define the name of the dog, Sammy, Frankie, whatever you happen to call your dog, and then we can define some sort of Boolean variable or even a string, whether or not it has spots. And here we saw we passed in the parameter as the user, and then it got assigned to the attribute over here. Now there may be attributes that are going to be the same for any instance of the dog class. For example, we know that it doesn't matter whether a dog has a certain breed, a certain name, whether or not it has spots, it's always going to be a mammal. So something we may want to do is have an attribute be defined at a class object level. Instead of having the particular instance always say that the dog is a mammal, instead we'll define an attribute above our init method here. So above this special method at the very start, we can define what's known as a class object attribute. And these are the same for any instance of a class. So let's go ahead and define a class object attribute. And what's special about these, since we know it's going to be the same for any instance of a class, we don't use the self keyword, because we know that the self keyword is a reference to this particular instance of a class. But since the class object attribute is the same for any instance of a class, we can just say something like the species attribute is equal to mammal. Now, as a quick note, if you're familiar with biological scientific classification, technically species is the wrong word to use here. That goes kingdom, phylum, and then later on class. And class is actually where mammal falls, but I don't want to end up accidentally using the class keyword twice here. So instead, we'll just pretend that the species of a dog is a mammal. Okay, so that's the side note for biology. But basically what we have here, back to Python, the class object attribute is going to be the same for any instance of a class. So let's test out this theory. I'm going to add this class object attribute. Again, note how I'm not using the self keyword because it's going to be true regardless of the instance. I rerun that cell, and if I call dog again and do shift tab, I still only need to define breed, name, and spots. So let's say the breed is again a lab. We'll say the name is equal to Sam, and spots, we'll say false, Sammy doesn't have spots. So I rerun this, now I have my dog ready to go. It's still a dog, and if I look at .tab here, I can see breed, name, and species. So species, even though we didn't define it, it's always available to us, and this is going to be the same, mammal, regardless of the instance of my dog. So it doesn't matter what I pass in for breed, name, or spots. Because this attribute is not connected to self, it's not connected to any particular instance, so it's a class object attribute. And the way we format it is we have the class keyword, the name of the class, and then any class object attributes, and then you have your special init method for user-defined attributes. Okay, so those are the basics of attributes, mainly from the previous lecture for user-defined attributes, and then we have class object attributes. What I want to do now is actually discuss methods. Methods are essentially functions defined inside the body of the class, and they're used to perform operations that sometimes utilize the actual attributes of the object we created. So you can basically think of methods as functions acting on an object that take the object itself into account through the use of the self argument or self keyword. So what we'll do here is create our first method. So again, methods, unlike attributes, are more like actions. So these are operations / actions, and we can think of these formally as methods. And they basically look like functions inside of a class. And a lot of times beginners ask me, hey, what's the difference between a function and a method? Basically, a method is a function that is inside of a class that will actually work with the object in some way. So let's define DEF, and let's define an action for this dog to take. For example, maybe our dog could bark. And what we're going to do is say self. That way we connect this to the actual object so the dog can bark. And what's going to happen is when you call .bark on the actual dog instance, it's going to print something. And let's have it print woof. And let's go ahead and delete the name. Well, let's delete the spots attribute, so we're not dealing with so many attributes here. I'll delete spots here as well, and I'm going to rerun this. So we'll rerun this cell, and now if we take a look at my dog, shift tab here, it only needs the breed and the name. So let's define a breed for this dog again. We're going to say lab. Notice now I'm not bother passing the actual argument name there and just putting them in order. And then the next one was the name of the dog. So we'll have the name of the dog be Frankie. So I rerun this, and now I have my Frankie, which is a lab here, and the type is dog. And if we take a look at the species, it's still a mammal, and now the name of the dog is Frankie. So one of the key differences between attributes and methods is in the way we call them. Notice that attributes never had open and closed parentheses, and that's because attributes aren't really something that you execute. Instead, it's just something that's a characteristic of the object that you call back. So it's just information there about the actual dog. And I'm going to zoom out one level so we can see everything together here. So as I mentioned, for the attributes themselves, there's nothing to actually execute. Now for methods, that's a little different. And in fact, methods will need to be executed. So that means we need to have the open and closed parentheses when we do a method call. And I'll show you why. So right now I have my dog. And my dog is a mammal, it's a lab, and it's Frankie. And I want my dog to bark. If I just call bark right now with no open closed parentheses, you'll get back something that looks like this. And this basically says, hey, you have this method that's bound to your object, dog, at this location at your computer's memory. If you actually want to execute the bark method, you have open and closed parentheses, you run that, and then you get back whatever the actual method does. In this case, it's just printing out woof. So that's how a method works. It's basically just an action that the actual object can take. In this case, it didn't really do anything besides the print statement, but usually methods are going to use information about the object itself. And we know that information about a particular instance of the object could be something like the name. So let's have the dog bark its own name. In this case, we'll say wolf, and here we're going to say my name is, and we'll use dot format here to pass in the actual dog's name. Now, a really common mistake that people do when they're first learning about object-oriented programming is they just pass in name. However, when we're working with objects, that's actually not good enough. What we need to do is reference the particular instance of the dog's name, meaning we need to reference not name, but self.name. Because when you pass the name at the beginning, it gets connected to the object through the use of this self keyword. So here we need to say self.name. And that's going to, when you run bark, it's going to say print wolf, my name is, and it's going to say, hey, what is this dog's name? For this particular instance of the dog object, find its name. And it does that through the self.name call. And then we'll just insert it automatically because we only have one curly brace there. So we run that, and we're using print formatting there, which you can always review in case you're unfamiliar with this format call. Again, we'll say lab Frankie, rerun all of this to make sure that the bark operation has been set. And now, when we call bark, it's going to say woof, my name is Frankie. So it's able to actually reference things in the attribute sector. So you're able to say self.name and pass that in successfully into bark. Notice here how we call the self automatically. That way, in case we ever need to reference things, it knows what instance of the object it's talking about. Now, methods can take outside arguments, so we can pass it some other argument here. So we could say pass in some number. So what we could do here is when you call bark, you need to pass in some number. So we'll say woof, my name is blank, and the number is, and we'll say comma number. So note the difference here. I'm no longer saying self.number because number is already being provided for us when we actually call bark. So that means we need to actually pass in a number call. So I'm going to again rerun everything to make the changes to bark here. Rerun lab Frankie, rerun this, rerun that. And now my dog, if I hit tab here, it has bark, breed, name, and species. So what we're going to do is call bark. And if I just call bark like this, so let me zoom in very quickly. Let me delete the old line here. So if I just call bark like this, I'm now going to get an error. It's going to say, hey, bark's missing one required positional argument, number. So now this method is expecting some sort of added argument, number, because when this dog barks, it's going to say its name and the number you passed, because I'm passing it in here with number. Again, note here now I'm not using self.number because the user is provided that. It's not referencing some particular attribute for that instance of the class, like the breed or the name. So let's give it a number to bark for us. We'll say 10. Run that, and then it says, woof, my name is Frankie, and the number is 10. And those are the basics of using a method for a class. You say def, the name of your method. Notice now we're using lowercase, so it follows the conventions of a normal function call, except it's inside of a class. And then you pass in always the self keyword, and then you can work with other attributes by referencing them in a self.manner, or you can pass in new arguments that the user provides and reference those as well, no longer needing the self call because it's not connected to a particular instance of the class. It's just something that the user provides for you when they make the call. Okay, so we went over methods right now. I'm going to start a new class just to really drive the point home. So make a couple of new cells here, and I'm going to create a class called circle. So my circle class, let's give it a class object attribute. And remember, a class object attribute is something that should be true when you have any instance of the class. So for example, I know that pi is going to be equal to, more or less, 3.14, no matter how big a circle is. So I will set that as a class object attribute. So regardless of the instance of a circle I make, I will always be able to reference pi up here as 3.14. So now we create our init method. This is a special method. We always pass in self. So it's very common to forget that when you're first starting to work with objects, but you always pass in self. And now whatever we need to define a circle. So an argument we may need to define a circle is a radius. And just like when we learned about functions, we can actually provide default parameters here. So we'll define a default parameter of 1. So that's a default value for the radius. And I will say self dot radius is equal to the radius that was passed in. And then I'm going to make a method here. So now we have our method. And we'll say this method is called get circumference. And what this does is it has in self, so it can reference the particular instance of the object. And it's going to, no, I'm returning it. I'm not printing it out. I'm going to return the actual circumference of the circle. So if you do a little bit of math, you know that circumference of a circle is the radius of that circle times pi times 2. So 2 pi r is the circumference of a circle. I run that, and let's create an instance of the circle. So I can say my circle is equal to circle. And then when I call my circle here and hit dot, tab, I can have get circumference, and I can actually see here I have pi, and here I have radius. And I actually spelled circumference wrong, but let's actually fix that real quick. Circumference. Now I rerun this, rerun circle, hit tab, and now I see get circumference, pi, and radius. So let's call pi, see what happens. We get back 3.14, makes sense, it's a class object attribute. It's an attribute that's going to be the same regardless of what instance of the class. Then I'm going to say my circle dot, and let's call it radius, and it's 1. So why is radius 1? Because that was the default value I provided up here. What I could have done is provided another value for radius. Let's provide maybe 30 for radius here. And then it would have just overwritten default value. So then when I call radius again, after rerunning that, assignments, I have 30. So you can have a default value here, and you can always overwrite it. Okay, so now let's see what happens when we call this method. We'll call my circle, and I will get the circumference, open close parentheses, run that, and it returns back the circumference, in this case 188.4. Now those are the basics of methods, and I want to come back up here and show you a couple more things that you may consider when working with object-oriented programming. One thing to consider is that if you have an attribute, it doesn't necessarily have to be defined from a particular parameter call. So for example, I can create an attribute for the area. So a circle can have an area attribute, and I can say self.area is equal to the radius that's passed in times the radius that's passed in times pi. So pi r squared is the area of a circle. So I can say self.pi. And now I will have an area when I define the circle. So I can say circle 30, my circle.pi radius, and if I call my circle here and ask for the area back, I get back the area of that circle. The last thing I want to point out is because this is a class object attribute, I actually have two ways of calling it. I could say self.py because self references a particular instance of this object, or something people sometimes like to do is actually say circle.py if it's a class object attribute. So if it's a class object attribute, you can reference it in this manner, which is the name of the class and then the attribute, because you know this is going to be the same regardless of the instance of the class. So you may see it this way as well. And sometimes programmers prefer it this way because if you're reading someone else's code, it's very easy to see down the line, oh, this is a reference to a class object attribute. So it may be obvious here because our class is smaller, but you can imagine if we had hundreds of methods, instead of saying self.py here, it might be nice to say circle.py. That way when you're on line 101 or whatever it is, you can see here, oh, they're referencing a class object attribute at the very top of this class. So you run this and you'll get back all the same results. It'll all work exactly the same. So again, you can use self.py, or to really make it clear that it's a class object attribute, the name of the class dot the attribute name. All right, that's it for the basics of methods. Coming up next, we're going to discuss inheritance and polymorphism. We'll see you at the next lecture. Welcome back everyone to part 3 on our discussion of object-oriented programming. In this lecture, we're going to specifically focus on inheritance and polymorphism. And inheritance is basically a way to form new classes using classes that have already been defined. Let's jump to Jupyter Notebook and see how this works. Okay, so let's begin by talking about inheritance. And as we just mentioned, it's a way to form new classes using classes that have already been defined. And really important benefits of inheritance are the ability to reuse code that you've already worked on and to reduce the complexity of a program. So we'll start off by creating what's called a base class. So this base class is going to be called animal, and it's going to be a very simple class. In fact, its init method isn't actually going to take in any arguments. Instead, all it's going to do is print animal created. So we have a very simple class here. So for instance, if I made an instance of animal, it would just print out animal created because this init method gets automatically executed when you actually create an animal. Let's add on two more methods, one called whoami, and all this is going to do is print out I am an animal, and we'll have another method here called eat, and this is going to print out I am eating. Okay, so we can see that if we have an animal here, we can do dot tab and we can ask it to eat. So open close parentheses to actually execute eating, and see print out I am eating. And the other one was whoami, and it'll report back I am an animal. This is going to serve as our base class. So newly formed classes can use the animal class in order to inherit some of its methods that you may want to use again. So for example, if I want to create another instance of the dog class, or actually recreate the dog class, so I'm going to recreate the dog class, but I start thinking, hey, a lot of the features and methods of my animal class are useful to a dog. For instance, dogs, they like to eat, so maybe I want to reuse some of my prior work in my new class. The way I can do that is by inheriting the base class, this animal class. So I'm going to pass in animal here. Before we weren't passing anything, but now if I pass an animal, I'm going to inherit or derive from this base class. So this is now known as a derived class because I'm deriving some of my features from this base class of animal. So I'm going to say dog inherits animal, and then in my init call, what I'm going to do is call animal dot underscore underscore init underscore underscore self. So I'm going to actually create an instance of the animal class when I create an instance of my dog class. And I'm able to do that because I'm inheriting from the animal class. And what I'm also going to do is print out dog created. So let me run that, and I'm running that with Alt-Enter so I can get a cell right below. So I have my base class of animal, and then I have my other class of dog, which is now going to inherit the methods of the animal because inside my init method, I called animal.initMethod self. So now let's see this in action. I'm going to say my dog is equal to dog. And I run this, and now I see that an animal is created because when I run this line of dog, this init method gets called, which in turn runs the init method off animal, which in turn prints out animal created. And then after that's created, I print out dog created. But here's where it gets interesting. All those old methods that were available for the animal, whoami and eat, are now available for my dog. So even though inside this dog class, I don't have eat or whoami defined, I'm still able to use them because I was able to derive them from my base class of animal. And that's the main idea behind inheritance. I can now reuse methods that should be common between classes by just inheriting. So I don't need to rewrite all these methods for my new class. Now you may be wondering, well, what if I want to overwrite one of the older methods? Well, that's actually no problem. All you need to do is say def in your new class, and then just make sure to use the same name as the old class method, such as whoami. And now, instead of saying I am an animal, we're going to print out I am a dog. So rerun this to make sure we've redefined it. Rerun my dog, and it still says animal created, dog created. I can still call eat, but now when I call my dog whoami, it says I am a dog. Before, it would have said I am an animal. So let's test that theory. I'm going to delete this, whoami, rerun this. We'll create our dog again, animal created, dog created, eat. And if I say whoami, notice I didn't overwrite it this time. It'll just say I am an animal. So you're able to overwrite the previous methods of your base class in case you need to. You're also able to add on methods. So, we're going to say def bark self, and then print out woof, so we can add methods and we can overwrite. So let me copy this eat method here and paste it in. And now I'm going to say I am a dog and eating. So I run this again. I recreate the instance of my dog here, animal created, dog created. And now if I call eat, it says I am a dog and eating because I overwrote the original method. I can still call whoami because I inherited from that base class, and it says I am an animal because I no longer overwrote it here. You can add in the method again call and then rerun this. But now I also have bark. So I could say my dog bark, and it will print out woof. The main ideas here is that all you need to do is inherit from your base class, and now you have access to all these old methods that you wanted. And if you ever want to overwrite them, you can just overwrite them as so, recall that same method name, and then do whatever you want there, and you can always add in more methods. So that's how inheritance works, and let's move on to discussing polymorphism. So we just learned that while functions can take in different arguments, methods belong to the objects they act on. Let's finish this lecture by talking about polymorphism. In Python, polymorphism refers to the way in which different object classes can share the same method name. And then those methods can be called from the same place even though a variety of different objects might be passed in. The best way to explain this is through an example. I'm going to create two new classes. I'm going to redefine my dog class, and then I'll also create a similar cat class. We'll say def init, and the dog just takes in a name, so you can name your dog. So we assign the dog's name attribute to the name that's passed in, and then the dog is going to be able to speak. And in this case, when it speaks, it's just going to return its own name, so self.name, plus we'll say says woof. So when the dog actually speaks, it reports back whatever name you assigned it, and then says woof. And I'm going to copy this, make sure I run this cell, and right below it, I'm going to create a very similar cat class. Same deal if it's init method, you provide it a name, but instead of speaking says woof, we're going to say speak says meow. So almost the same class, except the cat says meow and the dog says wolf. Okay, so I'm going to zoom out so we can see a little more of our code. We've defined the dog class and the cat class. Now let's create two instances of them. We'll say Nico is a dog with the name Nico, and we'll say Felix is the variable name for a cat with the string name Felix. So I'm going to print out what happens when Nico speaks. So Nico says woof. Looks like I forgot a space here, so let's clean that up a little bit. Rerun these two cells. Nico says woof, nice. We have a little space there. And then have Felix also speak. Notice here I'm actually executing speak with open close parentheses, and Felix says meow. So here we have a dog class and a cat class. Each of them has the speak method. When called, each object's speak method returns a result that's unique to the object. That is to say, it's unique for the dog to say wolf, and it's unique to the cat to say meow, as well as their names are going to be unique to that particular instance of the class. Now there's a few different ways to demonstrate polymorphism. One of them that's pretty simple is with a for loop. So I can say for pet class in, and now I'm going to say Nico and Felix. And what I'm going to do is I'm going to iterate through this list of items. And I want you to notice something here. I'm going to say print the type of pet class. And in fact, I'm just going to say pet, so that way I don't confuse you. So we'll say for every pet in this list, print what type of pet it is. So what type of class it is. And then also print what happens when you say pet.speak. So I run this, and this is an example of polymorphism. So both Nico and Felix share the same method name called speak. However, they are different types here. So notice we have main dog and then main cat. And let me remove this type call. They're both returning a string, but it then should be noted that one of them is saying wolf and one of them is saying meow. So another way to show this, besides iteration, is through a function. And this is probably the more common way to see it being used. And I can say def pet speak. So this takes in some pet. It doesn't really care if it's a dog or a cat, because what it's going to do inside of the function is just take that pet object and then call it to speak. So notice when I say Nico pet speak, it says Nico says woof. And if I were to pass in Felix to pet speak, it would say Felix says meow. So pet speak itself doesn't actually know whether you're going to pass in a dog or a cat. Remember, these are two different classes, and they are pretty similar in our case, but they could technically be wildly different. Dog could have 100 methods, cat could just have these 2 methods, but they share the same method name speak, which means I can leverage that capability by happening to either iterate through a list of these different classes and happen to call the same method name, or most likely I pass it into some function where later on it calls that method called speak. So in both cases, we're able to pass in different objects and we obtain object-specific results from the same mechanism, that same method call. Now, a more common practice is to use abstract classes and inheritance. And what an abstract class is one that never expects to be instantiated. You never actually expect to create an instance of this class. Instead, it's just designed to basically only serve as a base class. So we're going to say the animal class again. And the animal class is going to have an init method that takes in self name. This is the constructor of the class. And we're going to assign animals the attribute name based off what's passed in. And then this base class is going to have speak. However, later on in our code, we never actually expect to say something like my animal is equal to an instance of animal. In fact, this animal class is never actually expected to be instantiated. I don't expect to ever make an instance of the animal class. Instead, this is basically to be only used as a base class. So this speak method, and this is really common with polymorphism as you get into more advanced object-oriented programming, what we're going to do is raise an error. And we're going to learn about errors and exceptions in the next section of the course. But essentially what's going to do is say, hey, we have some sort of error here. So we'll say not implemented error. And we'll say subclass must implement this abstract method. So we run this, and what's going to happen is if we actually create an instance of animal, something which we're not expecting to do, so we'll say Fred is the name of this animal. If I say animal speak, I get back, hey, not implemented error. And this is actually telling me, hey, you're supposed to use a subclass to implement this abstract method. So the reason this is an abstract method is because in the base class itself, it doesn't actually do anything. It's expecting you to inherit the animal class and then overwrite the speak method. So I could delete this line because, as we just said, we never actually expect to use animal in that fashion. Instead, what we expect you to do is call dog and then pass in animal as you construct this dog class. And now you no longer need to have this sort of init method here. Instead, what you can do is say def speak self and then return self.name plus says woof. And we'll do the exact same thing for cat. So I'm going to copy and paste this. And then instead of saying dog, we'll say cat there. And instead of saying wolf, we'll say meow. Run that. I will say Fido is equal to a dog with the name Fido. And I will say Isis is an instance of cat with the name Isis. And now I can print out Fido speak. And now I can print out as well Isis speak, where Isis says meow. Okay, so some real life examples of polymorphism, since these are really basic examples of using the same method name and then also having these abstract methods, is maybe opening different file types. So you may want to have the method name called open, which makes sense. You're going to open a file. But there's lots of actually different files. There's Word files, PDF files, and Excel files. And if you were trying to make a class that could be a base class for opening files, and then you have other classes that would inherit that, maybe a class for opening CSVs, another class for opening Excels, another class for opening Word files, you'd want them to be able to share the same method name, the .open name. So that's a more realistic example, and that's an example of polymorphism, where you can have some function, maybe a general open file function, can take in any of those classes that you have and just call .open on them. And it's up to the class itself to decide what actual type of file is being opened. Okay, so that's polymorphism. Basic idea is you have these two separate classes that happen to share the same method name, allowing you to then call those same method names without needing to worry about the specific class that's being passed in. We'll finish off our entire discussion of object-oriented programming in the next lecture, where we finally go over special methods. We'll see you there. Welcome back, everyone. To finish off our series of lectures on actually working with object-oriented programming in Python, we're going to talk about special methods. Special methods allow us to use some built-in operations in Python, such as the length function or the print function, with our own user-created objects. To get an idea of how this all works, let's jump to a Jupyter Notebook. Let's start off with a simple example. I'm going to create a list, 1, 2, 3, and then let's say I wanted to check the length of my list. Well, I could just call len on my list. What if I wanted to check the length of one of my own objects? So to show you what's going to happen is if I create my own sample class, and it's a very simple class, we just say pass here. I create an instance of my sample, and then try to check the length of my sample. What's going to happen is I get a type error. Object of type sample has no length. And maybe I want to try to print out my sample. So I say print sample, and I just get back the report of where my sample object is located at my memory. Unlike my list, where if I tried to print it out, I would actually get back my list in a string form. So the question arises, how am I able to actually use built-in Python functions such as length or print with my own user-defined objects? And this is where those special methods come into play. So special methods, some people also call them magic methods or dunder methods because they use double underscores, work in the following manner. And there's more special methods than what we're going to show here, But for now, these are the main ones you're going to be using. I'm going to create a book class, and we'll say init, and init was the first special method we learned about, and it's special because it's basically called automatically when you create the object. So our books are going to have a title, an author, and pages. And what we're going to do here is say self.title of the book is equal to the title you pass in when you create it. The author attribute is equal to the author you pass in when you create it. And then the pages attribute is equal to the pages that you pass in when you create your instance of your book. And let's imagine I wanted to print out my book. Right now, if I say B is equal to book, where the title is Python Rocks, let's say the author is Jose, and it has 200 pages. If I try to print my book, it just says, hey, you have this book object in memory. What happens is when you call the print function, what the print function does is it asks what is the string representation of B. So if I try to cast or transform B into a string, what happens is I just get a string version of this report when I print it. Instead, what we can do is actually use the special method related to that string call, which is underscore underscore str underscore underscore. And what this does, if there's ever any function that asks for the string representation of your book class, then it's going to return whatever this method returns, which is why it's a special method. And make sure you use return here, not print. And I'm going to return whatever I want to be printed out. So when I print out a book, it might make sense to kind of print out a lot of things. So we'll use an f-string literal format. I will say self.title by self.author and shift enter here. So what happens is when I'm going to call the print function asks the book object, hey, do you have a string representation of yourself? To which the book object then says, yes, I do, because I have this special str method, and I return this string. Where the string, using f-string literal formatting, I can actually pass in self.title, so it grabs this title, and self.author, so it grabs this author. So let's rerun these cells, and now if I say print B, I get back Python Rocks by Jose. So if I ask for the string representation, it's the same thing, because the print function, all it does is it prints out what string representation returns back. So that's the special method for strings and printing in general. Next, we can do the same thing for length, because right now if I try to check the length of my book B, it says, hey, object of type book has no length. So as you may have guessed, the special method that goes along with this is len, and we're going to say self here, and then we can return back whatever we want to be printed out when you ask for the length of the book. And here, it probably makes the most sense to just return back the number of pages the book has. So we'll return back self pages. I rerun these things, and when I print these books out and ask for their length, I get back 200. Finally, what we could do is, let's say we wanted to delete a book. What you can do is you can call the keyword del space and then pass in the variable name, and that will actually delete that book from the memory on your computer. So if you ask for B again, it's going to say name error, B is not defined. So this is a way to delete variables from your computer's memory. Sometimes you may want to print out a report upon deleting the variable, or you may want other things to occur when you delete the variable. In order to basically specify extra things that may occur when you call delete, you can use underscore underscore del underscore underscore self, and then we can add certain things to happen when you actually delete an instance of the book. So I will say print a book object has been deleted. And then I will say shift run here, or shift enter. Let's define our book again, and let's print out the book. I'll do alt enter here to get some cells below. So I printed out my book. Let's check to make sure the book still exists. Print B, and then to delete the variable, I can say del B. And now when I run this, I get out the extra statement, a book object has been deleted. So when I call B again, it's now deleted, B is no longer defined, and I was able to add a print statement to maybe give the user more information when they use the special del keyword. All right, those are the main special methods that you're going to be using as you're just starting off with Python. You can check the documentation for many more dunder or special or magic methods, but really these are the main ones you're going to be using, especially str, and len. So again, str, it returns back the actual string representation, so you can print out user-defined objects. Len returns back the length, so you can return back the length of user-defined objects. And that ends our discussion on object-oriented programming. Let's now test your skills with a homework assignment and a small challenge project. Welcome back, everybody. Now that we've gone over a series of lectures showing you how to work with Python for object-oriented programming, let's test your new skills by giving you a quick homework assignment. I'm going to go over the notebook that contains this homework assignment. Alright, so here I am at the GitHub repo just to show you where the notebook is available. If you go to Complete Python 3 Bootcamp under the Object-Oriented Programming folder, you can find the Object-Oriented Programming Homework notebook. And it's the notebook that's right after that main lecture notebook about object-oriented programming. And this homework assignment has two simple problems. If you recall, during the lectures, we created a circle object, so we could create instances of a circle, and that circle object had a radius. So what you're going to be doing is something similar. We're going to use geometry to create two different objects. We'll have a line object and a cylinder object, or a line class and a cylinder class. Let's go over the first one. So here we have three methods for you to fill out. One is the first special init method. The second is the distance method, and the third is this slope method. So what we expect to be able to do is given two coordinates in the form of a tuple. So we have xy coordinates, coordinate 1 at x equals 3, y equals 2, coordinate 2 at x equals 8, y equals 10, or really whatever numbers. You'd be able to pass in those coordinates. Remember, they're tuples. And then using that, you'd be able to call the distance method to get back the distance between these 2 points, and the slope method to get the slope between these 2 points. And you can just Google around for the actual formulas for distance and slope, but in case you want to pause your screen real quick, here's the actual distance formula given 2 points. So it's just x of 2 minus x of 1 squared plus y of 2 minus y of 1 squared, and then take the square root of that, where you have y2 and x2 are 1 point, and then x1 and y1 are the other point. So that's the distance formula. And the slope formula, as you may recall, is just y2 minus y1, x2 minus x1. So these are the formulas that you're going to be using, and you're going to take in these coordinates and convert those formulas into method calls here that end up basically returning the result of that formula. And then we have problem 2, which is quite similar to that circle class, except this time it's a cylinder. So what you need to do is, again, fill out this form right here to set the attributes, and then have volume method filled out and surface area. And you can always Google search the Wikipedia page for a cylinder. They have the formulas for the volume and surface area of a cylinder there. So an example output is given a cylinder with a height of 2 and a radius of 3 units. Pass the volume method to actually get a volume back, and then execute the surface area method to get the surface area. And that's basically it for this quick homework assignment. I would say go with problem 2 first, actually, because it tends to be a little simpler than the line class, in case you want a more gradual pacing. Okay, we'll see you at the very next lecture where we go over the solutions. Best of luck, and remember that the coordinates here are being passed in as tuples. We'll see you at the solutions. Welcome back, everybody. Let's now go over the solutions for the homework assignment from the previous lecture. Alright, so here we are. We first had the line class, so let's start with that one. Remember that we're taking in these coordinates as tuples. So there's lots of different ways you could have done this. One way is to create the two coordinates as attributes. So we could say self.coordinate 1 is equal to the coordinate 1 that's passed in, and then self.coordinate 2 is equal to that second coordinate that's passed in. So this is one way to do it. And then later on, what you do is just tuple unpacking to grab the individual components of these tuples. So for example, in the distance formula, we know the distance formula at the end of the day should look something like this. It should be x2 minus x1 to the power of 2, and then we'll say plus y2 minus y1 to the power of 2, and then this whole thing squared. So one way to do that is just to the power of 0.5. So that's one way to take the distance formula, and in order to get x2 and x1, what we could have done is just tuple unpacking here. I could have said x1, y1 is equal to self.coordinate 1, and then x2, y2 is equal to self.coordinate 2. So you could have done it this way. The other approach you could have taken is just right off the bat, when you actually create attributes, is create an attribute for each of these. So you could say self.x1 is equal to coordinate 1, and then maybe use some indexing here. It's really up to you what approach you want to take. The main idea being that eventually you have to realize you need to somehow extract the actual components of that tuple, either through indexing or through tuple unpacking. And this is something that I wanted you to get practice with because often you're not going to just pass in single variables into your argument calls. They may be something like a list or a tuple, so you should have classes that are able to work with that. Finally, let's have the slope equation. And we can just copy and paste these lines from up here. And then for the slope, we just return rise over run. So rise is y2 minus y1. And then we're going to divide that by x2 minus x1. We'll run that, and then let's check this out. So we'll say C1 is equal to 3, 2 coordinate, C2 is equal to 8, 10 coordinate. I'll create my line object and pass in C1 and C2 here. And now I'll check out the method calls. We'll say distance, open close parentheses, because we execute that. And that looks like it matches up. And then we say my line, check the slope, and looks like that matches up as well. If you're getting different numbers for distance and slope, given these two coordinates, double check your actual equations here. You may have mixed up x1 and x2, or y2 and y1. So keep that in mind. These should be the results you get for distance and slope given these coordinates. So definitely check your math if you're not getting those same results. It's really easy to make a typo here or use parentheses in the wrong way. So just keep that in mind as you continue. Now we're going to move along to this cylinder class. So as I mentioned when we were going over the homework, this one's actually a little simpler than that line class. So here we have height and radius. Notice they have default height and radius. What I'm going to do is make those both attributes straight up since they're integers being passed in. So self.height attribute is equal to height, and then the instance's radius is going to be equal to the radius that is passed in. And then we're going to just return the volume equation. The volume for a cylinder, you could have Googled this. It's basically just height times pi. We could have also done a class object attribute there, but I'll just pass in 3.14. And then it's going to be the radius. So self.radius to the power of 2. And notice here how I'm using self.height and self.radius inside these method calls because I need to reference the instance of the object's own height and own radius. I can't just reference height and radius by itself. I need that self parameter. Then for surface area, this one's a little more complicated of a formula. Basically, you have the top and bottom of the cylinder, which is pi r squared. So I'm going to say that the top of the cylinder is pi r squared. So self radius to the power of 2. There's a top and bottom, so for the whole surface area, I'm going to return 2 times top, 1 for the top, 1 for the bottom, and then plus the rest of the formula, which is 2 times pi times self.radius times self.height. And the formula is basically just grabbing that middle section of the cylinder and then flattening it out so you actually get a rectangle. Okay, so that's surface area. Let's run this and make sure that our results match up. So I'll say my cylinder or my cyl, call the cylinder right here, 2, 3. We'll say c.volume. And it looks like I have an error, name C, whoops, my cylinder, not C. 56.52, perfect. And let's check out my cylinder surface area. Run that, and we have 94.2. Okay, so this should have been pretty straightforward, especially because it's very similar to the circle class. If you're having any issues on this, or there's something that's confusing to you as far as creating these methods, please post to the Q&A forums, and we're happy to give further explanation. I'm going to give a quick overview of what we just did here. So let's start with the line class. First thing we have to realize is that these coordinates are being passed in as tuples, and you have various options of how you want to work with these here. Either you can do the unpacking in your actual attributes, so then you can have self.x1, self.x2, and so on, or once you assign these coordinates, you can do the unpacking in the methods themselves. Again, totally up to you. Then just make sure that you're applying these equations correctly for both distance and slope. For the cylinder, it's a very similar thing. We assign the attributes height and radius, and then we just return back the actual mathematical formulas for volume and surface area of a cylinder. All right, thanks everyone. Again, if you have any questions, post to the Q&A forums, and we're happy to help you out there. We'll see you at the next lecture. Welcome back, everybody. We just had your homework assignment for object-oriented programming, where we had two geometric classes that were basically structured, and you just had to fill in a couple of lines in the attributes and methods part of that class object. Now for your challenge, it's going to be a little more freeform, and we're going to have you create a bank account object with a couple of attributes and a couple of methods, as well as some important special methods and self-checks. So let's go to the challenge notebook and explain what we expect you to do. All right, so here I am at the repo, and this should be the same if you've downloaded the notes, but under the Object-Oriented Programming folder, you should be able to find the OOP challenge. And in this Object-Oriented Programming challenge, we're going to want you to create a bank account that has two attributes, an owner attribute and a balance attribute. And then there's going to be two methods for that attribute, deposit to deposit money to your bank account, and withdraw to withdraw money from your bank account. And as an added requirement, withdrawals may not exceed the available balance. So for this withdraw method, you're going to have some sort of if statement to check, are you drawing too much? So here, we basically only have class account and then pass. So this is a little more freeform because it's going to be up to you to fill out the init method, the deposit method, the withdraw method, and then the owner and balance attributes. So once you instantiate the class with an owner, which is going to be a string, the name of the owner, and some current balance, so some initial balance for the account, you should be able to print out the object. Recall that there are special methods, specifically the str special method, that allows you to print out whatever you want when you call print on your object. So in this case, I have the account owner and the balance. You don't need to format your str method exactly like this, but you should be able to report back some useful information. Then you should also have the owner attribute, in this case the owner is Jose, and the balance attribute, in this case the current balance is $100. Then you can make a series of deposits and withdrawals. So the deposit 50, we deposit and actually add in $50 to the balance, so that should affect the current balance. And then we should be able to withdraw money, and we see withdrawal accepted, so we withdrew $75 from the balance. Now if you make a withdrawal that exceeds the available balance, in this case we try to withdraw 500, you should be able to see funds unavailable as the output. Okay, so that's your challenge for this object-oriented programming assignment. And I quickly want to touch upon this idea of being able to call methods that affect attributes. We haven't truly seen that yet, so I want to show you a very simple example. I'm going to create a class, and this is going to be a simple class, so I'm just calling it simple. And the init method, all we're going to do is say some value here. And we'll say self.value is equal to the value passed. And then I'm going to have a method called add to value. And this will be self. And then some amount. And what this does is it takes in the current value of self, or current self.value, and then it says self.value plus the amount. And this is something that we haven't really done before, because notice here, this method actually doesn't return anything. All it does is it takes the amount that's passed in, and then it adds it to the value. So this is kind of a hint of what you're going to need to do in your bank account class. So I'll say my object is equal to an instance of simple, and we'll say that the current value is 300. So when I call my object value attribute, I get back 300. You can kind of think of this as akin to the balance of the bank account class. And if I say my object and I call add to value, let's say add another 500 to my value, notice nothing is returned. Because all that's happening when you call this method is it takes in the amount you passed in. Here it's 500. It grabs your current value, notice the self call, adds the amount to it, and then reassigns self.value to reflect this change. So now when I call in my object value, it's 800. Okay, so that's basically the little example I wanted to show you of how you would actually grab a current attribute and then affect a change on it. And it's up to you if you want to print something like, we just added curly braces to your value, and then you could say something like .format amount. So if we rerun this, I would then get back an actual printed message here, just so I know that it's actually working. Okay, best of luck on that challenge. Again, it's definitely more free form because we want to push you to that next level where you're able to break down a concept into code. If you have any questions, feel free to post to the Q&A forums. In the next lecture, we'll go over an example solution. We'll see you there. Welcome back, everybody. In this lecture, we're going to go over an example solution for the OOP challenge. Remember, for this more open-ended project, your solution will probably vary than the one shown here, but as long as you're able to get the same results, it should be okay. Let's go to a Jupyter Notebook now. Okay, so let's begin by creating our account class. And I'm going to start off with the init method. We'll say self as always, and we know there's two attributes that are going to be defined here, the owner and the balance. And if we wanted to, we could set a default balance to be set equal to 0. That way we only need to provide the owner. That's optional. And we'll say owner is equal to the owner that's passed in. And we'll say the balance of this instance is equal to the balance that's passed in. Next, what we're going to do is set up our deposit and withdraw methods. So we'll say deposit self, and we're going to need some amount to deposit. So we'll say deposit amount, or dep underscore AMT for short. And what we do here is we grab our current balance and we'll set it equal to our current balance plus that deposited amount. And then what we can do is instead of returning anything, we can just print out added blank to the balance. And we can use f-string literals if we want here, or .format, whatever you prefer, and then just pass in the amount. Now for the withdrawal, it's going to be a little different because remember the withdrawal should check whether or not you have enough funds. So that means we're probably going to need an if statement here. So we'll say withdrawal amount, and we'll say if self.balance is greater than or equal to the withdrawal amount, then self.balance is going to be equal to the current self.balance, and I'm just using tab to autocomplete here, minus the withdrawal amount. And then I'm going to print out withdrawal accepted. Else, that means that the balance is less than the withdrawal amount. I'm going to print, sorry, not enough funds. Then after all of this, I want to be able to print out my account object. So I will have the special str dunder method. It'll just take in self. And here we can decide what we're going to return. It's really up to you, but in our case, I'm going to return the owner. So we'll say owner is curly braces, balance is curly braces. And if we wanted a new line to be printed, as we did in the example, we could say / new line. And then you can either use .format or string literals. If you wanted a string literal, you just put an F there and then pass in the information. So in our case, it's self.owner, and for the balance, it's self.balance. Okay, so remember, you need to return that for the string function. You don't just print it out. And let's try to create an account here and see if we get any errors. We'll say Sam is the owner, and Sam's going to have 500 as their balance. So let's check that we can grab the owner. Sam's looking good. Let's check that we can grab the balance. 500, that's looking good. Now let's see what happens when we print out A. We get owner Sam, balance 500. Let's make a deposit. So I'm going to make a $100 deposit. Added 100 to the balance. Let's print out A again, make sure that the balance has been affected. Great, now we see 600 there. Let's make a withdrawal of, let's do 600 itself to empty out the account. So that worked out. We'll print A. Our current balance is 0. Now if I try to do one more withdrawal of anything, I should get an error because I have a balance of 0. Or at least I should get a print statement. Okay, sorry, not enough funds. And if I print out A, we can confirm that I have 0. All right, that's all you had to do for this project. Let's do a quick little overview. We set up our attributes so that the instance of owner and balance were equal to whatever you passed in here. We have a simple deposit method, and as a quick note, for these actions of equal to the same thing plus, what you could do as an alternative is instead of writing equals self.balance plus, is just say plus equals. And it's the same thing over here. You could have just said minus equals. So this is kind of sleeker, but it's up to you what's more readable. So you could have done that for the deposit and withdrawal methods. Remember, the withdrawal method needed to have an if statement in order to check that we had enough money in the balance. And then for the string method, we just return back really whatever you want, as long as it conveys the information of the owner in the balance. Okay, you can check out the solutions for more information, and if you have any questions, post to the Q&A forums, and we're happy to help you out there. We'll see you at the next lecture.